Hello everyone, in today's lecture we are going to see the effort and schedule calculation in basic COCOMO. COCOMO is one of the most generally used software estimation models in the world. COCOMO predicts the efforts and schedule of a software product based on the size of the software. In this video, we will see effort and schedule calculation in basic COCOMO. COCOMO, constructive cost model. It is based on regression analysis. So what is regression analysis? It is a quantitative prediction of one variable from the values of another. Second one, it is a statistical technique used to find a relationship between variables for the purpose of predicting future values. The next one is procedures for finding the mathematical functions that best describes the relationship between a dependent variable and one or more independent variables. So, COCOMO is a regression analysis model. We have three types of modes in COCOMO. First one is organic, semi-detached, and third one is embedded. Now let's see one after the other. First mode is organic. That is, using organic mode, we can calculate the efforts and schedule of payroll calculation. Inventory and scientific calculation also we can do. In this mode, the project team is small. Little innovation is required and constraints and deadlines are few. Development environment is stable. Semi-detached mode. In this mode, compilers, database system, editors kind of software can be taken into consideration. Project team is medium size. Some innovation is required. Constraints and deadlines are moderate. Development environment is somewhat fluid. The third one is embedded mode. Real-time systems such as air traffic control, ATMs, weapon systems kind of softwares can be used in this method. Project team is large, a great deal of innovation is required, constraints and deadlines are tight, development environment consists of many complex interfaces including those with hardware and with customers. So this is the comparison of three modes. First, organic mode. The product size can be from 2 to 50 KLOC and it's a small project. Innovation, little bit of innovation is needed and the deadline and constraints are not tight. And the development environment is stable. Semi-detached. It is about 50 to 30 KLOC and it's a medium project. Medium innovation is needed and deadline and constraints are also medium. Then development environment is also medium. Third mode, embedded mode. Above 300 KLOC, product size is needed. Here the product and project team size is also large. Greater innovation is needed. Deadline and constraints are large in this method and development environment is also complex. We have three levels in COCOMO. First one is basic, second one is intermediate and third one is detailed. In basic level, it uses only size and mode and it determines effort and schedule. It is useful for fast and rough estimates of small to medium size projects. That is, in basic COCOMO, we only use size and mode and we will calculate effort and schedule. In intermediate COCOMO, we use size, mode and 15 additional variables to determine effort. The additional variables are called cost drivers. It is divided into four categories. One is product, personal, computer and project attributes. Then these cost drivers are named as environmental adjustment factor, that is EAF. Detailed COCOMO. This level builds upon intermediate COCOMO by introducing the additional capabilities of phase sensitive effort multipliers and a 3-level product hierarchy. Now let's see about basic COCOMO. Effort E is equal to A into size to the power of B. Here size means thousands of line of code, that is KLOC. We are going to calculate E, that is effort, that is equal to A into size to the power of B, where A and B are constant derived from regression analysis. So E, effort expressed in staff month. Now we have 3 modes, right? So when we take organic mode, we have to give A value as 2.1, B value as 1.05. When we use the mode as semi-detached, we have to give the value A as 3.0, B as 1.12. It is standard values. In embedded mode, we have to give A value for 3.6 and B value 1.20. So when we calculate E is equal to, that is for organic, E is equal to 2.4 into size to the power of 1.05. Likewise, in semi-detached, E is equal to 3.0 into S to the power of 1.12. Embedded, E is equal to 3.6 into S to the power of 1.20. Then for TDEV, development time formula, we have to use 2.5 into E to the power of 0.38 months. For semi-detached model, 2.5 into E to the power of 0.35. Next one, embedded model, 2.5 into E to the power of 0.32. So for organic, we have to give 0.38, for semi-detached 0.35 and embedded 0.32. Then for calculating the average number of staff members, the formula is effort divided by TDEV, and the productivity is equal to size divided by effort. Suppose that a project was estimated to be 200 KLOC and the mode is equal to organic. We have to calculate the effort by using the formula 2.4 into 200 to the power of 1.05. And TDEV is equal to 2.4 into E to the power of 0.38. We are taking organic mode. So when we have KLOC as 200, when it is the organic mode, we have to use 2.4 into 200 to the power of 1.05. If it is semi-detached, we have to use 3.0 into 200 to the power of 1.12. And if it is embedded model, we have to use 3.6 into 200 to the power of 1.20 to calculate effort. Then the next example is, we are using the line of code as 7.5 and it is organic model. So the effort is calculated using 2.4 KLOC to the power of 1.05. So we are getting 20 staff month. Then TDEV is calculated using 2.5 into SM to the power of 0.38. We are getting 8 months. And we have to calculate the staff members as well as productivity. So staff is equal to effort divided by TDEV. We are getting 2.5 staff members. And productivity is equal to size divided by effort. We are getting 375 LOC staff month. Hope you all enjoyed the session. Thank you.